It is another Tuesday afternoon. I think it can only mean some physical sciences. Igama lami nguThobile, and you are watching Mindset Live. Today's show is brought to you by Liberty, so a big shout out to Liberty. Thank you guys so much for sponsoring the show. We really do appreciate it. And matriculants, if you haven't done it yet, please download the Tenfold education app. That is where we can get all the questions that you're sending through. And remember, I do know that it's exam revision. You guys are writing prelims. So make sure that you send through as many questions as you can so that we can actually help you answer all the questions. I know it's a little bit stressful now and so forth as you guys have started, but I must say I'm really, really proud of you guys. I can see how much you guys are actually working. Some of you guys are sending questions in the AMs. I love it. So without wasting any more time, let's start with today's show. So in today's show, we are doing revision. So it's paper 1 or paper 2 questions. It doesn't really matter. But like how I always do it, I'm going to show you how you need to answer, what the examiner is expecting, where your marks actually come from. And then I'm going to try to go a little bit in so I can just teach you for those of you guys who do not understand the concept. So the first question I have today is actually a chemistry question paper. So it's chemistry paper 2. It is one of my favorite. It's organic chemistry. Now remember, with organic chemistry, you cannot fail this topic. Most of you guys fail it because you do not read. There's a lot of theory, there's a lot of background knowledge, there's a lot of linking of concepts and so forth. But once you have mastered that, you can answer any question, I promise. So the first question that we have, they've given us a block over here, and it says the balanced equation for the polymerization reaction is below. So now already I must remember, with polymerization or with polymers, there are many chains that are put next to each other and so forth. So they have broken down double or triple bonds and they've made it single chains because poly means many, right? So that's already polymerization. So another thing I can see, the N here already shows me that I'm talking about polymers. I'm seeing another N there. I can see that we have a double bond there. Remember, double bond is alkenes for the name ending. And then all of a sudden here we've got single chain, which is ene. I know now with polymerization, I break double bonds and form many single chains that are held together. So the first one says we must write down the following. So with 4.1.1, it says the type of polymerization reaction represented by the equation. Now already you can see I had a double bond here and I've got a single bond here. Remember, in organic chemistry, when we have a double bond, let me just take it back to grade 10. In grade 10, we've learned that around the carbon, we need to have 4 lines, meaning each line is 2 electrons. It must complete the octet rule by having 8 electrons. When we have a double bond, it means that each line counts 2 electrons. So that means I have a double bond, so I only have 2 hydrogens above each carbon. Now what happens is when we actually are adding something, we break away the double bond and then we have 2 new open spaces. For us to move from a double bond to a single chain, it means we have added something. If we were doing the reverse, if I had single chains and then all of a sudden I've got double bonds, it means something was taken away from the reaction. In this case, I've got a double bond, then I've got single chains. Something was added. The type of reaction is an addition reaction. So for 4.1.1, I have an addition reaction. 4.1.1 is an addition reaction. Now always try to write in full sentences so that the examiner knows that you actually understand everything. So with 4.2, it says the IUPAC name of the monomer. Let me take you back to the foundation of organic chemistry. In organic chemistry, there is a certain system that we use to actually name our molecules, where we look for the longest chain, our side chains, alphabetical order, and so forth. That naming system in organic chemistry is called the IUPAC system. For your information, guys, I would also know what IUPAC actually stands for. In some question papers, they actually ask you, what is the acronym IUPAC actually stand for? Or they might give you the whole word and they tell you, how do we abbreviate this word? So you must know either or. So the IUPAC is the naming system that we use in organic chemistry. So in this case, they want to know, name the IUPAC of the monomer. The word mono in chemistry means 1. Now remember, in chemistry, we also have our own way of naming. For an example, if we've got 2 things, we can say di, 3 is tri, 4 is tetra. Now, the mono means the 1. So let's see, the IUPAC name of the monomer that they're talking about is the first one. So let's see. So that it must be ethene because, let me just go back here. When we have one carbon, it is meth. When we've got two, it is eth. That is the name we name ethene. Ethene, the name ending for a double bond is ene because it belongs to the alkanes. 4.1.3. Now remember, again with organic chemistry, another thing that you need to always have in the back of your mind is the functional group in which it belongs and then the homologous series which it belongs. Now, I know most of you guys actually kind of confuse the two, but I want you guys to think of this. In the world, we have many different types of teas, right? We have homologous series, many different types of teas. However, we have chai tea, we've got black tea, we've got rooibos tea, and so forth. So those are the different functional groups that it belongs to. Each one has something distinct, right? Chai tea has a good smell, rooibos tea is good for this, and so forth. But they all fall under the category of tea. So it's the same thing when we talk about our functional groups and when we talk about a homologous series. You need to understand that when we're talking about alkanes, they only have single chains. However, when we bring in alcohols, there has to be an OH for it to actually belong to an alcohol. So when we start naming, even though it's given to you in a diagram, you need to actually identify the functional group and the homologous series that the organic molecule belongs to. So with 4.1.3, again, the IUPAC name, which is the naming system we use in organic chemistry of the polymer. The polymer that we have using is that one. Remember, it is a polymer because the double bond was broken and now it has single chains and it has many of these single chains. Again, polymer. So technically you have to use these two in conjunction. This was my monomer, which was my ethene. My polymer, I still have two carbons. One carbon is meth. Two carbons is eth. The only difference with naming organic molecules and polymers is the name, the prefix that actually comes before. So here we had ethene. If it's a polymer, we just put the word poly in front of it. So it's polyethene. You still say ethene even though we only have single chains, but it shows that it is a polymer. And I know that because of the brackets, the solid brackets that it has around it. So let's go on. So now we have one of these ones. So 4.2 says propan 1-ol. I can see it belongs to an alcohol. So you're going to ask me, Tobile, how do you know this? Because the name ending for alcohols belongs with an ol. The only way you can do organic chemistry if you understand functional groups and homologous series. So propan 1-ol undergoes two different reactions. Now we know with reactions, it can be addition reactions or elimination reactions and so forth. Now it is shown in the diagram below. So guys, with something like this is how it works for me, and this is how I've also taught my children. Sometimes when the examiner gives you a picture like this and you're not able to see how many carbons, whether there's a double bond, a triple bond, and so forth, it does get confusing. Not all of us can see it with the naked eye and so forth. It does make it easier if you redraw the structure, especially where like propan 1-ol, and you actually draw the whole molecular structure and not only write the name. Then you are able to see if there's a double bond, a triple bond, if we were to subtract something or if we were to add something, where would it be? And you also know where is that alcohol actually sitting, because it really does play a big role when you start having to answer questions. So what I've done in the next slide, I actually redrew the whole thing to make it easier. So I'm going to go to that one now. So I've redrawn the whole structure. I've drawn my propan 1-ol. I know prop means 3. Ol means there's an oxygen. So 1 means on the first carbon, that is where the oxygen is attached. The first reaction, I've got hydrochloric acid. On reaction 3, I've got water and sulfuric acid. And they've already told me that this is my major product. Now remember, we can either have a major product or we can have a minor product. With these two, we use Zaitsev or Markovnikov's rule. So let's see what the question is saying. So I just redrew that structure. So for 4.2.1, it says the type of reaction that is represented by reaction 2. I can see I've got propan 1-ol here, and then I've got H2SO4 right over here. Now remember, it is concentrated sulfuric acid. Now know that sulfuric acid is a dehydrating agent, so it will eliminate something out of that. Let me just go here, go to this one here. So this is 4.2.1. So we need to know the type of reaction that's happening to reaction 2. I've got H2SO4 right over here. So this will be a dehydrating reaction because concentrated sulfuric acid, which is H2SO4, will eliminate. So this is a dehydration. Or you can also call it an elimination reaction. So sometimes the examiner also likes being difficult and they'll tell you it's an elimination reaction, but be specific on the type of elimination reaction that it is. That it's a dehydration reaction because we are eliminating water. How I always remember it, if you hydrate, you are actually drinking water. If you dehydrated, you need water, right? Water has been taken out of your system. So it's a dehydration or it's an elimination reaction. If they are specific on the type of elimination reaction, then you're right, dehydration. But how did I know this? Because I know my rules of chemistry, that sulfuric acid will then eliminate. Let's look at our next question. So the next question says, what is the function of the concentrated sulfuric acid in reaction 2? Now, we already said it. It is a dehydrating. This is 4.2.1. So I'm going to give you various ones. I know that it's only 1 mark, but it acts as a catalyst. That's the first one. It acts as a catalyst. Now let's just talk about catalyst a little bit. You must also know the definition of a catalyst, and especially when we are doing like the industrial process of fertilizers, ammonia, contact process and all that stuff, you need to know the different catalysts that are actually used in the production of those fertilizers. Anyhow, a catalyst, they are substances that take place or they speed up the reaction rate by taking place without actually being involved themselves. How do they do this? They lower the activation energy of the reaction and then the reaction actually then speeds up and goes a little bit more quicker. Remember, they can ask you the definition of a catalyst or they can give you a graph and ask you whether a catalyst was used or not. So you need to know whichever direction that the examiner can actually throw the question that you can actually answer it. So sulfuric acid, the first one, we can say that it is a catalyst or it is a dehydrating agent. Why is it a dehydrating agent, Tops? Because it went through a dehydration reaction and an elimination reaction. So it is a dehydrating agent. So it eliminates water. Let me say dehydrating because Janet will kill me. Dehydrating agent. We can also say it causes dehydration. This is now in a reaction. It will cause dehydration or it removes water molecules. It removes water molecules. So you can have said any one of these ones. I don't think the examiners would have been angry with you. You're still using proper chemistry terminology. Let's look at the next one. Now they're telling us we must write the IUPAC name of compound X. The IUPAC name is the naming system that we use in organic chemistry. Compound X is the one here. So let's see. We had propan-1-ol. We eliminated something and then we have compound X. So let's see what we have there. We come back here, I'm going to go to my structure. Now remember, we remove water molecules. So in this reaction here, I already have an OH that must be removed, and I'm also going to remove another hydrogen. So now remember, if I remove these two, if in organic chemistry, if you are eliminating something, you're taking something out, you are actually moving from single chains to double bonds, or you're moving from double bonds to triple bonds, depending on what you're given. In this case, I only had single chains, and then I remove water, meaning I've got 2 lines that actually don't have friends. And remember, if there's nothing bonded at the end, it's not an organic molecule. So we form a double bond somewhere. The name will change from the homologous series will change from alkanes to alkenes because now we've got a double bond. I had propan-1-ol. Now I'm going to have, let me just first write, this is 4.2.3. So propan-1-ol, which was over here, will move to prop-1-ene. Propene. So we form a double bond on the first carbon because we've removed the H and we also remove another H. And remember, 2 H's removed and an O gives us H2O. H2O is what we formally know as water. So that is the reaction on compound Y. Can you see why important or how important it is to actually draw your structure like this? Eliminate the pictures in your structure and then you are able to say, aha, compound X is actually this. I think it makes it so much easier. Obviously, don't waste so much time drawing the perfect structure. Just redraw it in a way that you will understand. Now, the next question says we must draw the structural formula of compound Y, the structural formula. We must be very careful. Remember, there's different ways. Structural formula means you must show all the carbons and the hydrogens with all the numbers. So we start again over here. Why do I start over here? Because I know some of you guys actually confuse where to start, because they told us that propan 1-ol undergoes two different reactions. So the first reaction we went through this way. Now the second reaction we're going to go through this way. I've got propan 1-ol. Now I've got HCl. Now remember, it will dissociate into H plus and into Cl minus, and then I'm going to form compound Y. I want to go to my structure here. Got my HCl. So now I already have an OH here, and then I've got an H plus here and then a Cl here. Now remember, if we're not using concentrated sulfuric acid or NaOH or something, then we have an elimination reaction because water molecules were eliminated because they act as dehydrating agents. In this case, I've got HCl, which means it's going to be a substitution reaction somewhere, somehow. What is a substitution reaction? Take it like in football. If the players are playing and then one of the players is not really playing that good and then the referee actually says, change. They take out one player and then they replace it with another player. It's a substitution reaction. We still have single chains. We have no double bonds. We just took out the one and replaced it with something else. The name, however, does change according to the IUPAC system. The name ending also might change. So let's see what happens there. I've got HCl, and then I've got an OH, and now I must now think what is going to happen over here. I actually want to redraw the whole structure just in case somebody doesn't understand how we got it. Remember, I've got propan 1-ol here. I've got all my hydrogens around. I would love to say, please draw your hydrogens, and then I don't do it, but I know you guys do everything as teachers do. I'm going to add HCl to this reaction. This will become H plus and Cl minus. Let me just change color. So what happens is I'm going to take my Cl. It's going to be replaced on the OH's place. This OH and this H are going to form, if I've got two H's and one O, I form water. What do I get here? Let me summarize it here. I'm going to have my 3 carbons still. Substitution reaction. We substitute the OH with a Cl. I'm going to have all my hydrogens around it. It is not an organic molecule if you do not have your hydrogens. You get marks for having your hydrogens, so make sure you do not upset your examiners, plus H2O, because it is also a byproduct of this. Now remember, a reaction is in a straight line. I don't have space though, so that is why I worked in this direction. Substitution reaction, we substituted the OH with the Cl, and then this is what the examiner is looking for. The examiner wants to see that on this exact carbon, you actually substituted the OH with the Cl. Why didn't I substitute it with the H? Because the Cl must move there so that we can actually form water. Because if I substitute the H, then I'm going to get ClOH, which is not what we're looking for. I need to have water. How did I know this? If you're looking at it in a diagram like this, remember, if it's drawn out, you can see what needs to be substituted. It means I'm moving from an alcohol and I'm moving from a Cl, right? So that is then what the question actually required us to do. Let's look at the next one. Now, 4.2.5 says the type of reaction that is represented by number C. The type of reaction that's represented by reaction number 3. So if I've got compound X here, let's just take our minds back. What happened at compound X? When I moved from propan 1-ol moving here, I had concentrated sulfuric acid. Sulfuric acid is a dehydrating agent, meaning it will remove water from an organic molecule. I moved from single chains and I had double bonds, propan 1-ene, that I had the 3 chains. Now with reaction number 3, I've got water, I've got concentrated H2SO4. So what is going to happen there? It means I need to break those double bonds and then I have to add something. This is reaction number C, which is then forming compound number Z. Let's go back to my diagram here. So let's go back here. I've got my propan 3-ol, I've got my OH. Remember here, we had a double bond, C, See on the first carbon, there was a double bond. So technically, it looks something like this over here. So if you do want, as you move along, you can just change your structures as well. Let me just move this one here. Then my carbons are correct. Now here I've got water and I've got H2SO4. I'm going to break the double bond by adding the water. Remember, water, which is H2O, will break up into OH minus and then H plus. I'm going to break the double bond, making it single chains. Just want to use a different color. I'm going to have an opening there. I'm going to have an opening there. But now remember, with compound number Z, they did tell me it's the major product. We can either form a major product or a minor product, depending on the rules of Zaitsev and Markovnikov. So I'm going to do that with you step by step. So that is 4.2.5. 4.2.5. I'm going to do both of them so that you know exactly what's happening. I want to take it from here. If I have a C, another C, a double bond C. Here we have a H, another H. Make sure that each carbon has got 4 lines around it. So this is what's happening. I'm going to add water to this one. I'm going to show you the difference between major and minor. I'm going to have an OH on this side, and then I'm going to have an H plus on this side. So this is what's going to happen to the first one. To the first one, I can either remove this double bond. I'm going to put, there's an opening there, there's another opening there. My OH will remain on this one, and then my H will add on to this one. Now remember, the rules say the OH can be attached once we've broken the double bond. Remember, there was a double bond there. Once we break the double bond, the OH attaches itself to the carbon with the least number of hydrogens. If I close this carbon here, if I close this whole carbon here, between these two carbons, this one only had one H attached to it. This one had 2 H's. The carbon with the least number of hydrogens was this carbon over here. So the OH will attach to the carbon with the least number of hydrogens, and the hydrogen atom will attach itself to the carbon with the most number of hydrogens. This one had 2. That's the first one. Let's look at another one. If we could now say this, we had a double bond there. This carbon here has got 2, this carbon has got 1, this one has 3. Remember, we most of the time we focus on the carbon where the double or the triple bond is. The water will dissociate into OH minus, which is a hydroxide, and then H plus. So let's see. If I was to remove, oopsie, I thought I had my rubber. If we were to remove this carbon, this double bond over there, remember, I just want to write it in blue so you know it's there. I have an opening there and I've got an opening there. The OH can also attach itself to this carbon. When the OH attaches itself to the carbon with the most number of hydrogens, and when the H plus attaches itself to the carbon with the least number of hydrogens. Now let's go back. When the OH attaches to the least number, this will be my major product. We get this according to Markovnikov and Zaitsev. This is my major product. And when the OH attaches itself after breaking the double bond on the carbon with the most number of hydrogens between the two, this will be my minor product. So you need to know these rules. If you are getting confused, I would say draw them, my darlings. It'll always make it much more easier. But that is what they wanted on 4.2.5. Let's go back to the question. I think we have one more question to answer here. Now they're telling us we must give the IUPAC name of compound Z, and remember they want the major product. So let's go back here. They want the major product. I can now see, let me just do it here, which is 4.2.6. Can I please redraw it, just in case somebody does not know how to actually name organic molecules? I'm going to show you how you do it. Remember, we just have all our hydrogens, and then this is an H. Let me just change the color. Step number 1 when you are naming organic molecules is your longest chain. In this case, we've got 1, 2, 3. 3 carbons in organic chemistry are named as prop. Another thing, if I could name it as 1, 2, 3, or I can say 1, 2, 3. But always remember that your functional group must always get the lowest number, In this case, we have no double bond, so my functional group will get the lowest number. Now, as you can see, if I name it in this way, it is still a 2. If I number it in this way, it is a 2. So on this second carbon, that is where my alcohol is. I just want to, let me write it down. Alcohol. The name ending for an alcohol is ol. Now we have to put everything together. First, we are guided by the number of carbons, which is prop, propan, the name changing. Remember, the suffix must change, so it becomes propan. On the second carbon, that is where my alcohol is, the functional group where alcohols belong, the name ending is an OH, so it becomes OH. So it's propan-2-ol, or you could have also said 2-propanol. 2-propanol. 2-propanol, or propanol as one word. So that is then how we had to name these organic molecules. I think that was the last question that we had. Yes. So now remember, with organic molecules, or organic chemistry rather, you must know your theory. As you saw how I was actually answering the questions, I was telling you, we have a naming system. This is how the naming system operates. These are the different types of reactions. Where do you get them? From your theory. When we have an elimination reaction, it's because we have to dehydrate something. When do we move from a single bond to a double bond, and vice versa? You need to sit down and you need to read organic chemistry. It is the easiest topic that you guys can get. It counts a lot of marks. But what I always say, the nicest thing about organic chemistry is that oxygen will always be oxygen, and a water molecule will always be H2O. You know, so you cannot fail something because you guys were lazy to read. So remember, sit down, read it, and practice, practice, practice. Another thing that I always tell my learners, if they say you must give the name to compound Z, which is propan-2-ol, also draw the structure of propanol. If they say draw the structure of this, also name the structure. So you know whether the examiner can give you a drawing or a name, you can actually maneuver from one to another. Remember, if something doesn't correspond or you're not getting the same answer, then it means you do not understand what that concept is saying. So make sure that you sit down and you practice. Remember, practice makes perfect.